Okay, so welcome again, everybody. We are switching the topic from Cheetah to CASS, and in these few slides, I'm going to give you the idea on how to go from the raw SFX data to electron density using CASS, CrystFEL, and PHENIX. The data will be the lysozyme gadolinium. And the objectives of this tutorial are first, convert the raw data that you record at LCLS, for example.
Karol?
Yeah?
Do you have an online tutorial, or this is the only? Have you have access to your?
So I have notes written in the Scratch folder that explain all the points that have to be made in order to do this. And I think this slide also will be available. So, but I don't have online tutorial now. Anything on the web page. So the first objective is to convert the raw data from XTC to HDF5 format using CASS. And then the second objective is to use CrystFEL on these converted data and index the images and then merge them into one data set. And then hopefully solve the lysozyme gadolinium structure using PHENIX autosolve. So it's the flow of this tutorial will be like that. We will get the raw data converted by CASS to HDF5 format. Then we will use CrystFEL to index the HDF5 images and merge all of them together into one HKF5 that will be readable by PHENIX, and then start the PHENIX autosolve procedure and hopefully obtain a structure of the lysozyme gadolinium. So I will be concentrating on explaining how the scripts are working and what is inside those scripts that control CASS and CrystFEL. So there are 4 main scripts for each part. So for CASS there's an ini file, and there's a config file. There's a script that starts the conversion, and there is a script that has the template to start the conversion. That's for for CASS. Similar thing is for CrystFEL. There's a text file that contains all the CrystFEL parameters that you can tweak, and the config file for CrystFEL with the paths and everything, the script that runs the CrystFEL, and also the template for the script to submit the jobs to the batch queue, batch farm. And those two parts of the analysis and scripts are connected by this one CSV file, which has all of the run numbers and associated dark files. So we will come, and it looks like that. So the run number 1 was a dark run, and then the second one contains data, and this is the run number with which this run, the dark run number with which this run, with which this run has to be used. Then the ini file for CASS and the CrystFEL ini file with CrystFEL parameters, and that's repeated for all the runs in this data set. So, and I wanted to mention that the SFX lysozyme gadolinium data is available online at the CXI DB, and it's very important that whenever you use it, you should cite it, because the development of this database depends on the growth and support of institutions. Okay, so we will get started with the step-by-step tutorial. So starting from scratch, from empty desktop, we want to SSH to LCLS data to LCLS computers For that we can use, for example, footing. I hope that you are following all the steps that I'm going to do, and that you will be issuing all the commands that I'm going to issue. And I will try to do it very slowly, and whenever you have a problem or you are not following, you can raise your hand, and then I can repeat this step. And we have lots of time, so it's okay. So we are going to log into PS login. We can try to increase the font. So that everybody sees me. Okay, so now we have logged into PS login. I hope that all of you followed this step and you have logged into PS login. Now what we need to do is to SSH to PS ANA. Has everybody SSH to PS ANA already? Okay. Now we have to change the directory to the scratch experimental folder, which is this. And I hope that you have your directory with your name inside the scratch folder, so that you can go inside this directory. For me it will be Nass. And now you should make a new directory which is named CASS tutorial. Then you should go to this directory, CASS tutorial.
So I'm sorry, everything is where you copy, so
okay.
No, just the way you explain.
So now you are inside this empty directory, and you want to copy all the scripts that are controlling the CASS analysis and processing from.
So I don't put the keys.
Scratch Nass scripts, all of them with the star. To this folder. Okay, and there are all of them here. Let's see how the queue is going.
Karol?
Yes?
It's easier. PSN as CSQ might be better. What I
So we are on PSN, so the key is on PSN, so, but we are already there.
there are only 4 jobs running in that queue, and there are
But you have specify.
Yes, so
One has fast
There
access to
is
data.
said here.
maybe I would like to ask everybody to issue this command.
Directed.
How about RM-FR star?
If you are happy with issuing this command, please issue this command so that we can free up all of the space in the queue, because we are going to now add a little bit more jobs to the queue. Again, the command is bkill0. So now all of your jobs from Cheetah should have been terminated. Let's see.
We should make sure it's on.
Okay, some of them were. Thank you. So we can continue with this with the scripts. So like I said, the file that controls both analysis steps with the CASS and the CrystFEL is this one, lysogd_run.csv. So we can have a look what is inside this file. Is it too fast or too slow?
So we were.
Okay.
So do you want us to run all of these commands in our directory or?
In your directory. In your directory and inside the CASS tutorial directory. So let's go back. So in your Scratch directory, you should go to your home directory. You should go to your directory with your name. In my case, it's Nass. Then you should make a directory called CASS tutorial.
Else I can skip this. Physical.
Then you should see to the CASS tutorial directory. And you should copy all of the files in my script directory to your CASS. Yes, from my Nass scripts.
Start. Where's the start of your keyboard?
So has everybody copied the script?
No. But I don't look at it.
Okay, never mind. So now let's have a look into the CSV file. It should contain all the run numbers and the associated dark files. Whenever there is a dark file, after a comma it says dark. And then the run numbers that contain data should look like that. And this is the dark file to use with this run. The ini file for CASS to use for this run. And the CrystFEL ini file to use for that run. And you should only have uncommented those two lines so that we don't submit all of the jobs to the queue, but just those two for everybody. Okay, so now we should edit the config file for CASS so that it points to your directory. So we should open it with an editor, and the config file for CASS is convert.cfg. If you can open this file, it will look like that. So now you have to change some of the paths. The base dir path is one of them, is the most important. So it should point to your CASS tutorial directory. So in my case it is Nass CASS and then CASS. Okay. Has everybody changed this line which points the base here to your username in Scratch, CASS tutorial/CASS? This is where all the output files from CASS will be written, and they will be in the subdirectories with ini files, a list of the files, the command files that were submitted to the queue with the dark color file, and this line points to the data directory, which in this case you don't have to change, it's okay. And it's pointing to the lifetime gathering of data. This is where all the HDF5 files will be written. This is where all the job outputs will be written. This is where all the logs will be written. And this is the prefix for the XTC file names. This is E240 minus R0, and this is okay. Because then CASS will add the run numbers here, 001, 002. And the rest is not so important right now. Okay, so we have now edited the submit file, convert config file. Let's see how the queue is doing. So if you still haven't issued this command, it will be very helpful if you do it. It's bkill0, because otherwise the queue will be clocked very quickly. Yeah?
Why don't you want to use PSN as CS queue?
We can also change to the other queue.
It looks like you look at your scripts, you have a hardwired queue name everywhere, and there's lots of slots open PSN and CS queue.
Okay. So to change the queue name, you have to edit this file, which is run template LCLS, and change that FEHCS.
PSN CS queue.
Okay, so like that.
I think that will work better given the number of people we have.
Okay, thank you.
Don't get as fast connectivity to the data that people
Karol, what was this file? Get it.
Run template.sh.
What?
I should change this line to PSANA CSQ.
Which file?
Run template LCLS. Yes?
It seems that in the submission script that is actually hard-coded for the load directory, because it says template files to be used for run. If you very also different points in the directory.
Okay, so convert CFG. And which line number?
line number.
I like to use Nass because it's very.
I don't know. I think for almost all
Other
of
people use BI.
almost the default.
Most of the code.
And others use VIM.
There. It says like SH template we use for S1. Isn't this the one that you just changed?
Okay, so this is the ini template.
That's
Sorry.
just another program.
This one.
Yeah.
Not another name.
So if you would change it in our directory, you could probably not do anything, right?
Exactly. So you should also change this line to your file name and your logins and CASS tutorial. Thanks.
Which file is this?
This is the convert.cscfg file. And the line is almost at the bottom, and it's called ini run template. Where is the lines of queue? run template.
Also, what about the first line? Directly where the analysis is taking place? Right at the top.
Just a second.
Yeah, we had that already.
This one, base div.
Yeah, we'll check that already.
Yes. And you should also have changed it already. Okay, so it looks like we have set up the convert.cfg file. So we are going to try to issue this command, which now will submit the conversion jobs to the LCRSQ. Has anybody done all these steps already? Yes, Nadia?
CFG. I already did. Go back.
Alright. So to start the conversion now, you should issue this command, sh convert underscore files.sh, and then the liso gd runs.csv.
So what else?
And see output like this. So it has submitted the conversion jobs, and it has submitted this job to convert the first run, the dark file, and now it's waiting for the dark card to appear because it doesn't exist yet, and it will wait for a little while until it starts to exist, and then it will submit the run number 2 with the dark card from the run number 1.
This one, yeah. Bro.
Well, it should be tutorial get faster
The queue was PS Anna CS Q. It's written here. PS Anna CS Q. So you see, after a while, the dark file has been created, and the script automatically recognized that dark archive has been created and submitted the conversion jobs for the run number 2.
Oh, that's why I gotta change. Well, I guess I gotta change.
And if you check whether the jobs are running, you can type this command, bjobs, and you see that my jobs are running. Here you should see your username.
Scripts.
It shouldn't take long. It will take about 5 or 6 minutes to convert this run. So has everybody reached to this step? Who has some problems?
Getting a wait and check again about
It's probably because there are so many jobs pending. I don't know. Let's have a look.
it took like 50 seconds or so. Get past that. So you keep clicking on each check. Yeah. Okay.
So now we can have a look what folders have been created in this CASS tutorial directory. And
So I think most of us are not ready because it's still running for most of us.
It might be that we have many people analyzing the same data. So I could imagine that we're getting serialized accessing the data. As a guess, that's why we're analyzing the same way.
All right. So the message is that you are still waiting to submit the jobs, right?
Best case
Waiting for the cal, the dark cal to finish. Waiting for the job to finish.
Everyone wants to access the same file.
So I will wait for.
But one wants to have the beginning and also all the time has to switch between those.
Everybody's batch jobs are all ready. Just waiting for them to complete.
If first we were served, same.
So now if you go into the CASS folder that has been created and type ls, you should see some new directories. And in this one, in HDF5, you'll see you have the HDF5 files that have been created, that are being created. For example, for run number 2, it's divided into slices. It goes to the slice 0. Oops. There's a directory AA that will contain HDF5 files. So now, while the jobs are running and we are waiting for them to finish, you can go back to the CASS tutorial directory and set up the indexing config file. And the indexing config file is this one, submit.cfg. You should try to edit it. And again, you should change some of the paths. The one that needs to be changed is the base here path, which should be changed to CASS tutorial. Okay, only this one.
Yeah, the problem is
So again,
the console was occupied.
the file name is submit.cfg. So change the base deal name, base deal path to your username, CASS tutorial CASS.
That results there.
No? PHP scratch KNAS CASS tutorial CASS. CASS KNAS CASS tutorial CASS. Or maybe. Yeah. Exactly like this. Your username CASS tutorial CASS. Now, the other file to edit is this one. We have to change the queue name. So we are going to edit the lcls underscore header.txt. And similarly to what we did before, we are going to change the queue name from this.
Which file is it?
SCLS header.txt.
Hello.
And we are changing this line to PS ANA CSQ.
So, this
In the meantime, you can issue this command and see what are your jobs doing. In my case, they are still running. I said 6 minutes, it's taking 9. It's probably because access to data is slower.
Did you just watch it?
So if everything is ready now, with your config files and headers files, to start indexing the run that hopefully has been already finished. It hasn't finished yet, but to do this, you should issue this command, sh run automated CrystFEL, and then the CSV file. Okay, so let's try. And it says that the run number 002 is still converting. Oh, it says that it has been converted, or seems to have been converted. And now it is submitting the indexing job to, no, sorry, I haven't changed it. It says this one, but it has submitted it to this one. So let's have a look. Few jobs. Oh, yeah. So I don't know why I submitted it, why it's still running. Probably there's something wrong with the subject config.
Didn't take that long, but I think because of it. Try to take it.
That's the same thing.
Like
Like 10 movies. If you take one of them and copy it to the other disk drive, the operating system is smart enough that it's one after the other. This is okay. This takes time. This is okay.
Well,
If you override this behavior and take one, copy it there, and before it is finished, take the other one, copy it there, it gets bad. If you take this back and copy it there, it gets worse. So if you take this forward, and so on.
Okay, so have you successfully submitted the indexing job?
This drive has to go somewhere else. This drive has
If
to
you
go
did that, yes?
Where's the indexing parameters?
Okay.
Should take.
I haven't said that. I haven't said that the indexing parameters are in CrystFEL.txt.
More or less, yes.
Here they are. I won't go through all of them. You can read all of that about that in the manual
I just
for CrystFEL.
understand this.
So the output file with the indexing should be in CASS indexing ref directory. You can have a look at the jobs output file. It should contain messages from IndexMagick, from CrystFEL. And it should look exactly like this. It says that most and direct doesn't work because we have forgotten to source the CrystFEL setup file. This happens very often. Now if we try to rerun it,
Oh, cool.
So, shows up.
So we are using the bash, say source, to import those paths. Then we need to find. So I think it is a change.
The results for the appears when you do a command.
so now the output file looks like that. The job is still running.
So what is the output file? Where is it? And what's this?
Output file should be in CASS
So he's using
indexing ref jobs indexing out.
C#. He executed setup minus SH. So he should have done it.
Yeah, and you see that there are some images that are indexable.
But we are using the bash, so we.
What's the source command for CrystFEL?
Yeah,
The source command for CrystFEL is
this one.
Yeah, I didn't.
Dot.
G. So I think you are using the C shell, so you should actually be using the minus CSH.
And you're bash, so that's the with the dot.
So hopefully all of you have gotten to this point. Who hasn't gotten to this point?
Yeah.
Okay, so what was the problem?
Instead of waiting for
That setup dot sh no minus.
version,
Says wait and check.
Waiting for
002 are still doing
I'm sure you're able to rerun the index.
yes. So that's very good because it is a sanity check. It won't start with the indexing job before the converting job is finished.
Start.
So once it's finished, you can rerun it and it will work.
No, that's okay. This just
You can do it all correct.
Can you speak up?
Do you literally convert every frame? Don't convert, makes it sound like you convert every frame.
No, we are doing hit finding.
How do you tweak it?
Exactly. So we have to tweak the hit finding parameters. We have to edit the ini file. It's this one. I didn't want to go into that because it's very long and complicated.
I just wanted to check.
Sorry. Sorry.
It contains all of the parameters that we can tweak. And the one that is responsible for hit finding is this one.
So everything is this.
It's called post-processor.
For these yeah, it's at the
And the post-processor number is 208.
everything is at the bottom.
And here's the threshold,
There is
the track pin diameter, minimum number of pixels, etc.
Those keys and you can switch between keys.
Okay.
And they are just
So we did that only for one run. You can of course edit the list of 3D runs if you are great. And uncomment all of them.
okay. Maybe do it like this.
Yeah, but I'm not sure that we're looking
okay.
for so much. It's not specific to
and start converting
Okay.
all of them at once.
I think it's PS
You can pause it.
Q.
You can pause it, put it in the back.
And we'll go and submit all the jobs like that
Here?
Yeah, you can do it Control X.
very quickly.
But I'm here, I'm logged in on the same machine as
How
them.
do you know?
There is a reason that because
Okay,
the
okay, I
menu lines
don't
for each
You're right.
different ones.
Then
Yes, there's a very good reason because
Control X?
during the experiment, to collect the data in runs, and every, let's say, hour, we want to collect a dark frame. And then,
So no problem actually putting them in one line. We'll still read it.
no, they can't be one line. They have all,
So now, okay,
all
now.
they have to be different.
Terrible
Yeah,
with
that's
you and
really
Leo.
insane.
So I'm very sorry. Let's try again.
Nothing is finished.
Okay, so once you have converted all of the runs and indexed all of the runs like I showed you,
It looks like you're the only one.
you're going to run
But maybe
this
if we're all
script,
accessing the same.
merge all.
That could be it.
And that will combine all of the string files from indexing into one large string file.
One to the left.
Then it will use one of the CrystFEL scripts to split the large string into two chunks. So it's the alternate string file. And splits the large string into two streams. Then it will perform the Monte Carlo integration, which is this process HKL command on both halves. Output HKL files. This is the point group and then the max AD that I was using. Everything above 9,500 counts will be discussed.
Someone else should be.
And then it will calculate some of the statistics using this commands. And finally merge the whole data set into one HKL file. I see that now it's going very slowly because we are clogging up the queue. And once you run on the merging script, you should have ended up with these files, dot, 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 dot. They contain the statistics from CrystFEL, and also this one is the merged HKL file. So now to go from CrystFEL format to, for example, XDS format, we are going to use the create xscale script, which is also here in the scripts directory. Let's have a look what's inside. It's a script that converts the HKL files and adds this header. So you can set up the lifetime leveling in unit cell and the space group and decide whether you want to let the previous row true or false.
So it doesn't want to override it?
And then you just run this script on this HKL file and create an XKL file.
SH.
Which we can then convert to an empty Z file. Yes?
Use to a reference.
No. It's all raw data indexed by CrystFEL without any reference. And during the merging together, there's no option for scaling to a reference. So now, from the XL, you can very easily go to an empty Z file by xdsconf. I hope you are familiar with that. we can open the XDS input file, put the input file here.
Can you follow?
Did you do
So when I look at
the source?
file, this out file,
No.
I don't see the source.
Okay.
Directly, source and crystal.
Do you have it?
Yes.
Which one?
This one.
When I go and type it, my sources, right? Yeah. And then not making it.
Alright. So I hope you saw what I was doing. So I converted this file, size of GTHKL, to an XK file, and then using XDSConf, I converted this one to an NTZ file. And now you can use this NTZ directly in PHENIX.
Can you show how you use this HDL file?
You have to use this script, batch all. And it will take all of the individual stream files from these subdirectories and create one big stream file. And then the command to create the HDL file from this stream is at the bottom. It's this one. It's the process HKL. It takes as an input the stream file and spits out the HKL file.
Yeah.
Yeah.
Used to find this picture. Okay, so it wasn't. I know that this is called
Okay. So it will take time for all of your jobs to finish, but once I hope you know now how to get to HKL file and then to MTZ, and then you can copy the MTZ file to your local machine and try to run PHENIX on it. So I have done this previously, so I will just go to the directory. It's this one. I just changed the name. You see, it has this unique code that you define in the create XK file, and it has these columns with structure factors and diamond.
I think I already did this.
And now we go to experimental phasing, autosolve.
So it's not important stuff.
You can load this MTZ file by
Yeah, but we don't need to do this. So we are at level.
dragging it from here to there. You have to also input the sequence file for lysozyme, which is S1 EDS, for example.
I can just
And the wavelength for this was, I forgot.
I can use SSH on this.
No, CrystFEL you can do it.
145.
Okay. Yeah.
And the atoms are gadoliniums, and there are two sides. and it's a sub data. Can just click run.
So, what is that source data?
And it will take some 20, 30 minutes.
This is the source data that file.
So I'm going to show you the results of the finished job that I did on exactly this file, which I finished yesterday, did yesterday.
What did you do?
So let's look at the explain results. The data quality, for example. This one shows, this plot shows the I over sigma. It looks good. I'm going to plot for 2.1 angstroms. It's above 5. And what is also important to look at, what Nick also mentioned yesterday, the NZ statistics.
So
for FEL data, this plot doesn't always look as good as this one, but you see that it's pretty good.
Sorry, I didn't.
And we can open the results. Good.
Obviously, so there is no pressures, and there is no whatever. There's no pressures. So we do this.
Okay, so the best density modified map. So it's this one. So let's try to find the gadolinium sites. So scrolling down. Oh, here are the gadolinium sites. And this is the field model.
And now we want
You see that the gadolinium sites in these complexes are coming back. And the map looks quite okay. It also puts some waters on them. And it requires only a little manual refinement. Okay, I'm only 3 minutes over time. Yes.
What are the sites bound to? What are the coordinating to?
Yes, that's a very good question. I don't remember, but I can find the answer.
Can you put up the symbol?
Yes, yes.
Because I can see the string.
okay.
It's this thing, HPDO3A. That's it. Is this a question?
Can you see the different session? Can you extend the map and the symbol?
Just direct because
These two gadolinium sites.
What's on the other side? Can you put on the symbol?
Sure.
but you can make this. Sorry, yeah, the keyboard is very much long. So okay, so I will try then.
The cluster compound.
Yes, it's the gadolinium HDP something.
It should have.
And it has those two sides.
Does it? One, okay.
I'm not a biologist, sorry.
It must be interactive.
Irrelevant?
I don't know.
Okay.
Just sitting in the solvent channel.
This.
Probably the answer will be
Yes.
here.
They want this HDF file, and probably we have okay, we're in an earlier step.
Okay.
We could easily